5. No, really? Huh. There we go. Okay.
I don't know if you need, can you hear, you can obviously hear me back there, okay? Yes. Great. All right, once again, thanks everybody. Good evening, welcome thank you for coming, and thank you, Dr. Lyon, for inviting me. My name is Paul Striebel. I'm a program manager at CCAT. The title of this presentation, as you can see, is Inside CCAT, Advanced Manufacturing and Beyond. What it really is kind of an overview of all that we do at CCAT. I've got quite a few slides here, so I'm going to go through them relatively quickly, so hopefully we have time for some questions at the end. So let's start out here by being honest. Before my introduction tonight, how many of you had heard of CCAT? Oh, good, a good number. How many of you knew what CCAT stood for? Well, I'm embarrassed to say that back in 2006, when I was looking for a new job opportunity, I had never heard of CCAT. What had happened is I actually posted my resume online, and one night I received a voice message on my home answering machine from a woman by the name of Lisa. She said she was from CCAT, and she was inviting me in for an interview. So naturally, the first thing I did is I turned to the internet, and I typed in CCAT.com.
Or SE.
And as you might expect, this is what I found. Well, having a background in manufacturing and being a longtime boat owner myself, I was pretty excited about the prospect of working for a manufacturer of boats. Unfortunately, during the interview, I was somewhat disappointed to find out that the company didn't actually build boats. But I was also intrigued by what CCAT stood for, and that is the Connecticut Center for Advanced Technology. At that point, the company was very much in its infancy. It had been incorporated less than 24 months. I think I was their 18th employee in an organization that has now grown to beyond 60 people. And as noted on the slide, we're located in East Hartford. We actually have 2 facilities in East Hartford, and I'll go over those in a little bit. Most of the information I'm going to show you tonight is available on our website, so if ever you have some time and you want to look us up, the URL is ccat.us. So now you know what CCAT stands for, about how many people we employ, and where we're located. So let me tell you what we do. And here it is. Leading, partnering, creating bold ideas for success. I know what you're thinking. That doesn't really say much, does it? And there's a reason for that. It's because we're continuously evolving and changing in response to new technologies and opportunities. So let's step back to 2004 when CCAT first came into being. The company was formed largely from a grant that was received from the Air Force. The Air Force money at that time was earmarked to research the use of lasers for producing aircraft parts more efficiently. The concern at that time was over the decline in Pratt & Whitney's business and the potential loss of their workforce from the area. Congressman John Larson, who's pictured in the upper left, he was instrumental in helping to start CCAT. And his former chief of staff, Elliot Ginsberg, now serves as our president and CEO. So who are we today? I guess you describe us as a multifaceted, nonprofit economic development organization. We're funded about 60% from the federal government. About 20% of our resources comes from the state of Connecticut, and the balance comes from commercial projects that we perform. Our services are concentrated in 4 areas, and the intent of each of our initiatives is to help small and medium-sized companies, municipalities, and other nonprofits grow and succeed. So our focus areas, as you can see on the screen, is with advanced manufacturing, energy, information technology, in education and workforce development. So hopefully you all recognize this picture. It's a picture of Hartford with the Connecticut Science Center shown in the middle. Just to put our location in perspective, if you were to swim across the river from the Science Center, you'd end up within sight of CCAT's headquarters. And for those of you who may not have visited us yet, this is a picture of our primary administrative office building, showing a picture of our lobby and one of our 6 state-of-the-art conference rooms. So the whole look and feel at CCAT is pretty modern and high-tech if you've been there. This is a picture of one of our conference rooms, which features a 3D movie theater. And you can see that screen in the background on this slide. Now within CCAT, these are some of the partner organizations that are actually located within our facility. Most of them are geared towards providing assistance to startup technology businesses. Perhaps you've worked with a few of these organizations. CCAT operates as a business incubator to startup technology companies. So what that means, at any given time, we can have up to 30 startup companies residing in our building. And they're there to take advantage of the resources and services that we and our partners offer. Now, pictured here is what we call the Wall of Fame. It's one of the walls in our building, and it shows the logos from the various startups that we've worked with. And as Dr. Lyon mentioned, in addition to running our own business incubator, CCAT leads the Connecticut Business Incubator Network, CBIN, which represents the other incubator facilities in the state. Now, CCAT also coordinates various entrepreneurial events and activities around the state. Pictured here are some successful business owners that participated in a lecture series that we called Lessons in Excellence. This was conducted at the various community colleges throughout the state. Now, we also start encouraging entrepreneurship at a pretty young age up in Hartford. These are pictures from an annual event that we call Lemonade Day. What Lemonade does is it encourages middle school students to set up and run their own lemonade stand or business for a day. It's a one-day event. It's generally held in May, and of course there's prizes. We give prizes for the best stand, the most revenue generated, and of course the best tasting lemonade. So not to digress too much from CCAT, but since most of you or many of you here are inventors and entrepreneurs, I'm just going to take a moment to point out one particular success story that came out of CCAT's incubator. RSL Fiber Systems, perhaps some of you have heard of them, where the RSL stands for Remote Source Lighting. This company started with 2 gentlemen in our incubator facility. They had an idea for combining laser-generated light with fiber optic cabling. What they did is they developed a system to replace the traditional electrical wiring and lighting components on a ship with light that's pumped from a laser, what they call a laser light engine, through fiber optic cables, all the way up to a reflective plate at the end of the cable. So if you think about it, their lighting system, it eliminates the use of traditional copper wiring, which is often affected by the corrosive nature of salt water on ships. It eliminates the need to replace light bulbs, which are often located in high and difficult to reach places because they use a reflector plate. And not to mention that light bulbs have a tendency to attract heat-seeking missiles, so it eliminated that threat as well. Their system makes use of a central control station which can rapidly turn on or off all lights and change colors of the lights instantaneously and as necessary. And lastly, their fiber optic cabling is also less expensive than traditional copper wiring. So with all these advantages, the company made their first dollar with a contract that they received from the Navy for $9 million. They've since equipped several fleets of naval and commercial vessels with their system, And they've now found other applications for this lighting system, such as if you think in mines and in caves also. So it's a small companies. Now, last I knew, they were well over 24 employees, and one of our graduates that we're pretty proud of. Now I want to take a moment just to talk a little bit about our Education and Workforce Development Initiative. By the way, we don't have departments or cells at CCAT, we call them initiatives. What our Education and Workforce team does is they create and they sell curriculum. They conduct summer and school year STEM programs for K through 12 students. They introduce students and families to the prospect of making a career in manufacturing. They offer professional development to help teachers adapt to new national standards. They work with the manufacturing community and job seekers to make effective job matches. And we also administer exams that assess manufacturing competencies. So it's a pretty interesting group. When you walk through our education area, it's common to see people playing with toys and conducting experiments as part of developing new hands-on curriculum. Here I believe Dr. Veith is testing the conductivity of a lemon for some reason. And in the background, he also has some kind of hydroponics farm taking shape on his desk. And I also want to mention that in 2010, CCAT sponsored the first all-girls robotics team. The name of the team was called Athena's Warriors, and it was led by one of our female engineers at CCAT. And in this engineering workshop, we challenged the students to build the tallest building possible out of nothing more than plastic cups. That's what they're doing there. Now, our education department, we also conduct a Young Manufacturers Summer Academy, and that introduces middle-aged school children to actual hands-on manufacturing. And in October, we helped the state celebrate Manufacturing Month by holding an event that we call Manufacturing Mania. And again, it's predominantly middle-aged students. They get to meet with manufacturers at this event, and they learn about how manufacturing's changed and the opportunities that are available in manufacturing these days.
Sir, you said middle-aged, you meant middle school, didn't you?
I did mean middle school, K through 12. Yes, typically 6th to 9th grade.
Right.
But you're welcome to join the activities this summer if you'd like. This is a popular manufacturing mania activity where the kids, we have a projector set up and the kids get to scan their hand, and we actually reproduce the hand on a 3D printer for them. And another one of the programs was called Launch Quest, which our educational department ran. And it actually introduced middle school students to rocket science. We had students build and launch their own model rockets here. And then we took it one step further, and we built a full-size version of the models. So here's the rocket mounted on a launch pad in New Mexico. And before we launched the rocket, we had each student's school, we gave them the opportunity to put some form of payload in the container that's shown in the center here. Now, some of the items that were placed in the container were pretty interesting and pretty sophisticated in some cases, including devices like altimeters and whatnot. And of course, these were middle school age students. So other schools opted to put more basic things like slices of pizza and chocolate chip cookies inside of the containers. So ultimately, the goal of this program was to return the payload to the students so that they could see the effects of zero gravity on the contents of their container. So in most instances, the students got their payload back to observe, but in the case of the unsuccessful launch shown on the right, the students lost their contents somewhere in the desert, and they learned the disappointing lesson that rocket science is not necessarily a simple science.
How high did the rocket go up? The successful one.
Yeah, the successful one, zero gravity. I'm not sure how many miles that might be. Anybody have an idea?
You'd be on the order of like 60, 70 miles if you got there. Is this actually like a middle school design project or?
No. The project was commercially built, funded by CCAT, and it was an educational program that we administered.
Yeah. Is it a solid or liquid
It has fuel. I'm sorry, I don't know what the propulsion.
Took the wide
Did I mention I come out of the finance department at CCAT? So although the Launch Quest program actually ended a few years ago, we still have a replica of the rocket in our building. So if you ever visit us, you'll see this in the hallway of our main entrance. All right, now we're going to turn to our energy initiative and a little bit about what they do. The energy team at CCAT is heavily involved in the support of hydrogen fuel cell technology. We actually lead the Connecticut Hydrogen Fuel Cell Coalition and also something called the Northeast Electrochemical Energy Storage Cluster. Hopefully some of you know what those groups are. They develop models for sustainable, reliable, and renewable energy. So in other words, for example, they decide where charging stations should be located throughout the state for electric and hydrogen vehicles. They lead planning and policy initiatives that focus on new technologies to offset energy demands. And they work with a number of state and federal agencies such as the Connecticut Department of Energy and Environmental Protection, as well as the U.S. Department of Agriculture and Energy. So this is actually one of the first fuel cell powered vehicles that Toyota produced, and it was given to our Director of Energy to drive for a while. So it was pretty neat to see him pull in the parking lot with his quiet vehicle every day. Although there was difficulty when he needed to refuel it because there was only 2 fueling stations in the state at that time. Some of you may not know that CCAT was also instrumental in getting the fuel cell powered buses that you see driving around Hartford introduced onto the streets. And this is an event we held at our facility several years ago where many of the major manufacturers brought their hydrogen-powered vehicles and they gave the public an opportunity to test drive them around our parking lot. And the gentleman on the left in this picture, he's the former U.S. Energy Director under the Obama administration. His name, I believe, is Ernest Moniz. He came to CCAT to meet with Joel Reinbold, who's our Director of Energy. And he's the gentleman that's pictured on the right in this slide. So let's turn to information technology in our IT initiative. Many people aren't aware that CCAT's even involved in information technology, but it's actually our largest initiative and accounts for almost half of the people in our organization. Our IT team provides services and solutions to schools, to towns, to libraries, and other nonprofit organizations. They're involved in pretty much the full gamut of IT services, from needs assessments to managing their infrastructure, data protection, disaster recovery efforts, website design, application, and hosting. They also get into voice over IP telephone services, and virtual desktop services for many of the clients that we support. So our IT department actually has a satellite facility in Jacksonville, Florida. So this is the 3rd location of CCAT, where we have several people located to assist with the IT needs of an organization called Big Brothers Big Sisters. You may have heard of that. We do the IT services for them and also for other nonprofit companies that are located down in this facility, which is the DuPont Center in Jacksonville. So I'm not sure if our IT people are basically lazy or if they just like to show off their digital toys. But if you call the folks in our IT department, they tend to show up at your desk in robot form rather than as a human being these days. These telepresence robots, as they're called, are basically an iPad on a stick, and they're remotely controlled by a keyboard. I don't know if you've seen these, but the Monday morning staff meetings that we hold are very interesting to watch, as you typically see several of these robots parading down the hallway and into our conference rooms. So it's quite a show. As I mentioned, we have two facilities in East Hartford. Our second facility is located directly behind United Technologies Research Center. We actually lease space from the research center, which is just a stone's throw from the UConn football stadium. Now this here is a picture of our Advanced Manufacturing Center, or AMC as we call it. It's a pretty nondescript building from the outside, but it houses some of the most sophisticated manufacturing equipment available in the world today. It's actually an ITAR-controlled facility, meaning that we perform some government work and that only U.S. citizens are permitted to enter.
Peter, could you tell us what that stands for, ITAR?
International Trade and Arms Regulations, I believe it is. So as I mentioned earlier, our advanced manufacturing facility was originally equipped primarily with laser equipment, and thus it used to be called our Laser Applications Lab. Now, as the facilities evolved and new technologies have emerged, the names of the building keeps changing to reflect the times. Typically, there's a ribbon cutting ceremony that goes along with each change. So again, it was originally called our Laser Applications Lab. It then became our Innovation Center. It then became our Regional Innovation Center as we entered partnerships with Massachusetts and Rhode Island. And now it's our Advanced Manufacturing Center. And you might recognize some of the people in this picture. From left to right is the Mayor of East Hartford, Marshall Leclerc. Of course, Governor Malloy. Third gentleman is Congressman Larson. Next to him is Congressman Joe Courtney. CCAT's chairman of the board, Dick Baxter. And on the far right is our current president and CEO, Elliot Ginsberg. So our Advanced Manufacturing Center, what do? They're involved in applied research and development of manufacturing technologies. They develop processes for the use of new technologies. They insert new technologies into the supply chain. And they perform precision quality control and produce 3D models from existing parts. Again, we work with here the U.S. Department of Defense, a number of small, medium-sized commercial customers, some large commercial customers as well, various national labs as well as the state of Connecticut. And this is a picture from some of the laser processing applications that CCAT was involved with early on. On the left was some drilling experimentation we did with lasers to try and drill irregularly shaped holes. In the center, we did a lot of research with using lasers for welding purposes. And in the lower right there, we're actually removing paint. We used lasers to do research for removing paint from different aircraft parts and whatnot. So today our facility is equipped with a variety of different machine tools. Many of the machines that you see in this picture are actually just consigned to CCAT, meaning we don't own them. The OEMs give them to us for purposes of letting us test and demonstrate their capabilities. So what's constantly happening is we're getting new machines in as new models and new features are developed. And this is a part that I actually have up here on the table. It was made on one of our 5-axis milling machines. Complex parts such as this Mobius strip can easily be machined these days in a single setup. And here's another part that I have on the table, and we can pass these around later if you'd like. We have several different 3D plastic printers. that can print using a variety of different materials. We even have one that can print using bulletproof Kevlar these days. The car that you see in the picture and the one that's on the table was produced in a single build on a Projet 3D printer. And that 3D printer can simultaneously print with 4 different materials. You'll notice when you see that car, it has a rubber material for the tires and various different plastic of varying diameters. Now, white light scanning. This technology is used for non-contact inspection and also for reverse engineering. The CCAT engineer shown in this picture actually built this white light scanning system from a variety of commercially available components. And his system, believe it or not, it boasts a very low cost while offering accuracy that is comparable to systems costing about 10 times as much. He's used this system to reverse engineer and produce a new gear. I don't know if you recall when the Mystic River Bridge got stuck. It turned out that it was a worn gear. They brought the gear up to us at CCAT. He scanned it with his white light system. We extrapolated new gear teeth, what they should have been originally, and then we produced the new gear and got the bridge up and running. What he's in the process of scanning now is he's digitally capturing bronze sculptures so that they can be reproduced if ever damaged or destroyed. And what's prompted this project, you may recall last year there was a statue in front of the Cult Armory that was actually stolen. It ended up going to a scrap dealer. It was destroyed and is irreplaceable. Had we had that statue digitally scanned and stored, we would have been able to rebuild it. So most of you are probably familiar with plastic 3D printing, but this machine does 3D printing in metal. What it does is it uses a powdered metal particle and a high-powered fiber laser to build parts, just one particle at a time. This additive machine is produced by a company called IACTpaul, and they're located in Albuquerque, New Mexico. The build platform inside of this is sealed, and we do the builds in an inert gas environment, typically argon. So additive manufacturing allows us to produce shapes that traditionally could not be made with a single machine tool in the past. It also allows us to build parts with new metallurgical properties, since we now have the ability to mix different powdered metals on the fly. I have a couple examples of that on the table that I'll show you. Actually, this part is here as well. Additive can also be used for such things as for repairs, such as repairing shafts or worn gear teeth, as I mentioned earlier. In this picture, we're building up the diameter of a shaft that's been worn over time. And here's the newest addition to our Advanced Manufacturing Center. Some of you may have seen the recent article in the Hartford Courant. This machine arrived in November. It's actually still being assembled in our facility. So what you're seeing here is just one piece of the machine that came off of the first of 7 flatbed trucks that delivered this massive machine. It's a machine that was built in Germany by a company named Zimmermann. And this machine is specifically designed for machining composite materials, which are becoming more prevalent in jet engines these days. Now, the machine, when assembled, will be over 20 feet tall, which actually presented a bit of a problem for our building, which only has 16-foot ceilings. So given the fixed height of the machine, we only had 2 options. One was to raise the ceiling or to lower the floor, and we opted to lower the floor. This is a picture of the construction company beginning to dig a 40-foot by 40-foot pit inside of our building about 10 months ago, before the composite machine arrived. And here's the final pit that the machine is currently being assembled in. It's bigger than most built-in swimming pools. The concrete in the bottom of this pit is over 3 feet thick due to the weight of the machine. And it also has a built-in water pumping system, since the hole we found out is below the water table and started filling up as we dug. So this is a rendering of what the final composite machine will look like, which should actually finally be completed and operational by the end of next month, the end of March is what we're hoping.
Who would use these Zimmerman machines?
Again, it's for machining composite materials.
I mean, what kinds of customers use this?
Well, it's for aircraft predominantly, GKN, Pratt & Whitney, and the like. General Electric's been used, my understanding is General Electric's been using composites for a long time. What's been happening is Pratt now is getting more and more into composites. The machining of composites are going to suppliers of GE out in Ohio, and thus we're trying to keep our supply chain employed. So the state subsidized heavily the purchase of this composite machine so that we can educate our Connecticut manufacturers on how exactly to machine composites.
Peter, how much
It's
would a
Paul,
machine?
okay.
Sorry. How much would a machine like that cost?
The list price on that machine is almost $3 million. It's 2.9. Yes.
Yeah, you named some very large companies. I'm surprised they can't afford these machines themselves.
What you mean? Large customers?
Well, I mean, like United Technologies,
Mhm.
they can't afford a machine of. Like
Oh, absolutely, they can, and they're very aware of this product. We will not. We actually are unable to do any repetitive manufacturing in our facility. We are strictly a research facility.
Okay.
So our objective is to bring that machine in, understand how it works, transfer our knowledge to the supply chain like Pratt and whatnot. Pratt will come into our facility, evaluate the machine, decide if they want to buy a Zimmerman or somebody else's. So that's pretty much the way our facility is set up. It's kind of unbiased manufacturing facility, a place where they can, manufacturers can come and evaluate different equipment. Yep.
So it sounds like you're gonna be generating a lot of reports about machinability, for example.
Mhm.
Are those reports publicly available, or do they go to the specific person who's funding the research?
Here again, it depends on the nature of the program that we're doing the work for. As I mentioned, being an ITAR facility, we do some work for the government that is proprietary. But for the most part, under the Freedom of Information Act, a lot of what we do is available.
Can inventors who don't have a business take advantage of your services?
Absolutely, the prototyping services, we actually have some monies from the state of Connecticut to subsidize the cost of having work done in our facility. Of course, the amount of those monies vary from year to year, depending on the state budget situation, but we certainly can take on certain projects. Let me just ahead here. Only a couple more. So yeah, basically to wrap out, I just want to point out that although at its core we focus on 4 areas, but we actually have pretty far-reaching tentacles, and we often find ourselves involved in the administration of other programs and events that help serve our mission. So for instance, what you see in this slide, for the past 10 years, CCAT's coordinated the State of Connecticut exhibit at either the Paris or Farnborough air shows. They alternate. This year is big air show is going to be in Paris. Next year it'll be in Farnborough. So each year for the past 10 years, we've represented the state of Connecticut. We bring over a number of small Connecticut aerospace parts manufacturers, give them the opportunity to exhibit inside of this booth. the cost of that is subsidized by the state in order to make it affordable for them to attend. It's, as you can imagine, it's very expensive to have an exhibit booth of your own, at either one of these shows. But as shown in the picture on the lower right, they do draw a lot of people. Generally, over 350,000 people attend the air shows each year. So finally, just briefly, I want to mention the program that I'm primarily involved with at the moment. Some of you may have heard of it. It's called the Manufacturing Voucher Program, or MVP. This program provides grants up to $50,000 to Connecticut manufacturers to help them become more efficient, productive, and competitive. So if you know of any manufacturers that could use an extra $50,000, have them give me a call. I'd be happy to explain all of the parameters, eligibility criteria for the program. And that's pretty much all I have to present formally. I'm certainly willing to take on some questions, but let me start passing some of these items around as well. So first you may have seen this one. I think it was in one of the slides. This is a part that was produced using the additive metal, powdered metal process. This is what we call a build plate. And from there, we're able to build this. It's a relatively slow process. I think it takes about 2 hours to produce something that size. But when you think about it, traditionally, this could not be produced on a traditional machine.
Is it fragile, or can you try to bend it?
So you can certainly try and bend it. And as I mentioned, we can mix different powders to get different material properties. You'll notice it sticks on this end, does not on this. So as you run this up and down there, one end is magnetic and the other is not. And that, again, was all done through additive by just using different powders.
Hey, could you explain to me why this cannot be manufactured by the traditional means?
Well, you could turn the OD on that, right? But what you're not seeing there, when it's half built, they do machining on the inside.
I see. Okay. This inside. Okay. Thank you.
And this part here, again, it's built from this plate up. You can see the actual rough build surface here.
Right.
But then it's also machined on top. It's all done by one machine. It's now called a hybrid additive machine. So this machine has 2 heads on it. One that actually does additive manufacturing, and the other one that's more of a traditional machine tool to do the subtractive final finish machining. In addition, it's considered a mill turn machine, in that the bed turns at very high RPM, so we can actually do turning on here. So we can add, subtract, and do turning.
How long to produce that?
This part, I believe, was about 8 hours in total.
Okay.
So it's not up to production speeds yet. It's just technology, but it is evolving.
It was just good for modeling.
Yeah, absolutely. And here again, this was all produced on one machine, one setup, about 8 hours. Mike, I'm sorry, just a second.
So where are you located?
In East Hartford, 2 facilities. Pitkin Street, right across the river from the Science Center. And the
So
other
swim
one,
across the river.
swim across the river. That's right. You might want to wait a couple of months. The river's still got some ice flowing down. And then all of this is produced on Pratt Whitney's campus, our facility there. As I mentioned, using different metals, you'll see that in the magnetic rod that I'm passing around. But if you look at this close, the major body of it is stainless steel, but these pads are actually bronze, all printed on the same machine using 2 different metals.
What are they? I'm sorry. What are they?
I believe it's bronze on
Bronze.
Yes. Also machined. So all is built, machined, multiple materials, one part.
How does the bronze stick to the steel?
It's fused via the laser, just like all the other particles stick. That started out as a microscope, very small.
So is Powder
Powder.
metal.
Pedal. Yeah, I should have brought some of the powder. Didn't think to do
For
that.
this Mobius belt, it is done in one
One fixture, one job.
Wow,
Yeah.
that's impressive.
Yeah.
Right, that's
5-axis
mathematic.
Yazda milling machine.
Right, that's, cannot do any.
I'm afraid the car didn't totally survive the actual car ride on the way down, but I think you'll get the gist of this. This again was done on a Projet 3D printer. Prints 4 different materials, so all of this was done in one build, and you'll see that the tires are rubber-like, got white plastic, you got dark plastic. Yeah, so we can do some pretty intricate 3D printing in plastic.
It came out of the build moving like that?
What you see is how it came out.
If you go to Maker's Fair, they actually have crescent wrenches made that
Yeah.
are functional.
Functional crescent, I've seen that.
If you go to Maker's Fair, fly open.
Do you have electronic capabilities for making printed circuit boards and doing PCB?
Not into that
Assembly.
yet. No. No, we'll leave that up to you. It's your expertise.
Oh, what sort of waste materials come from all this manufacturing? Do you have to do any sort of licensing with the state to make sure you're not polluting, or?
We actually, because we're researchers, we don't generate all that much scrap. A lot of it, frankly, gets reused since we grind it down and build it back up. But we do dispose of it through channels such as Clean Harbors and whatnot.
With the 3D machine, you don't have waste.
No, 3D you really don't.
It centers powder right in situ.
Wouldn't there be some gases coming off the sintering process?
There,
Could be dangerous.
there are. We have the whole facility has air ducts on it and ventilation and whatnot. Yes.
Hi, well, very interesting. You must have done labor saving studies. How many in the machine jobs, how many jobs you replace by this advanced tech?
I don't know if we've measured it in terms of job replacement. But one of the services that we provide for manufacturers that have jobs that are very long cycle times is they'll bring a part into us and we'll optimize the cycle for them. So we'll play around with different feed speeds, cutting tools. We have Kennametal and some of the other cutting tool manufacturers on site. So we will actually try and optimize that process. And I know in some cases, one in particular was 36 hours to produce the part. And they brought it down to, I believe it was like 8 or 9 hours. So they cut the cycle time substantially just through the use of different machinery and tools.
4 to 1.
Mm-hmm. Yes.
Do you give some of these like smaller companies referrals because maybe they can't buy the $3 million machine? Are you able to refer them
To people that have that kind of equipment. Sure, absolutely.
For the 3D printing of the plastics and the additive manufacturing of the metals, how much of an issue is the mechanical properties for both plastics and metals? The way you form something has a significant impact on
The metallurgical properties or physical
In the case of
properties.
plastics, the polymers get lined up, but they get cross-linked. And the case of the metals, you have
That's it. It's a great question. That's one of the big unknowns with this whole new technology right now. So a lot of the research and funding that we're getting revolves around, X-raying, cutting open, and studying the metallurgical, characteristics
It's definitely,
and the integrity. Because I don't think you'd want to see any of these additive parts, flying quite yet. Yes.
In the incubation space, you mentioned there's roughly 30 companies that can be in there at any time.
Mhm.
What type of services do you offer to those other than the physical space? They're obviously getting access to some services. What are they, and what's the available?
Right, I showed that one slide with some of the partner organizations
Yeah, I couldn't
that
figure
are
out the scope of
that are
what was
in
available.
their building. I mean, for instance, we partnered with local universities. The two primary ones that actually have and maintain an office is UConn and the University of Hartford. Both have a physical presence. For instance, usually every semester we'll get a call from a business school where they conduct programs with our startup businesses, usually marketing classes and whatnot. They'll do competitive analyses for a new startup business, show who the competitors are, what the competitors' price points are. So those about half a dozen startups per semester we'll send over there. They give a little pitch on what their idea is, what business they're trying to build. They get a team of 5 to 6 students working for them all semester. Okay, they go back at the end of the semester. The students give them a report on their findings. As a matter of fact, that one example I showed you, RSL Fiber Systems.
Yep.
They were strictly developing their system for the Navy and for ships, and they participated in the UHART class that one semester. And it was the students from that program that gave them the idea of getting into mines and caves and whatnot. And now it's a big part of their business.
Great.
So,
You guys are doing great work up there. I have to admit, you probably get up every morning smiling with work.
it's rewarding, and yeah, it's great to see some of the successes that we produce.
It's interesting, since you're state organized or state run or state funded or
Yeah, we're actually we're not even a quasi-state. We're actually independent, but we are a nonprofit organization funded by state and federal resources.
it's something that more people in the state of Connecticut should know about,
Mhm.
whether they're in manufacturing or not. The fact that there's a quasi governmental agency, however you want to say it,
Yeah.
nonprofit, that's advocating for people to stay in the state. This is something that
Yeah, well,
I
that's
think most people complain about government, and here's something that they're doing that's major, and most people don't even know about it. So you have not an advocacy, obviously, for groups like this, but an advocacy for a regular Joe, citizen, probably should know. I love the idea of hydrogen car driving,
Mhm.
because that's the public coming in. Do you guys offer regular events for regular members of the community to come in and see what you do, other than?
They vary. They're periodically. There are different events going on. You can monitor on our website. Everything's on there.
What are the strings for the $50,000?
The strings for the $50,000. The manufacturing voucher program that's funded by the Department of Economic and Community Development. I actually administer that program. We've funded over 400 companies thus far from that. In terms of strings, if there's any string, it's basically there's a reporting requirement 6 months after you receive the funding to make sure you use the funding in the
If
manner
you want to
you
use it
said.
to make 5 different
So
categories of products from your original,
yeah, eligibility
what was all that?
eligibility criteria. The primary criteria is you need to be a Connecticut manufacturing company.
Okay.
You need to be in business for at least 3 years and generating revenue. You need to be 3 employees or more, 3 full-time employees or more, and less than 300 employees. And also, you can propose any kind of project using a third-party provider. We will not provide funding for you to use in-house resources. It has to be done with an outside, so it could be buying a machine tool from a third-party vendor, or it can be bringing in a consulting firm to help you out.
Can you leapfrog over the 3-year requirement?
Leapfrog over it. You have to
Don't
be in
use it.
business. You have to be in business at least 3 years. If you're under 3 years in business, if you haven't been registered for 3 years, you're not eligible for the program. There's other programs for startup companies.
How much revenue do you have to generate?
We haven't had an issue. That's been a problem. If you've got three employees and you're doing at least 51% of your revenue comes from the sale of goods that you manufacture, you're potentially eligible. Yes,
The material, that magnetic and non-magnetic, is that stainless?
I believe so.
Okay, thank you.
Come on.
do you mind talking just for a minute about your invention?
My invention.
Yeah, that the IP clinic helped with. I think people would be interested in hearing about what happened there.
Okay. For the past 10 years, in addition to the manufacturing voucher program, I have been administering another program funded by DECD that provided revenue to startup technology companies that were housed in Connecticut incubators. So what I would do is I'd go around and I would vet all of these startups that had applied for funding through this program. They were in the various incubators, and I showed you there's about 16 of them in the state now. So in the past, I've had several part-time businesses myself, and I got the itch to do something else. I was inspired by seeing all these other companies being successful. So one day I was actually in our incubator facility. We were throwing out our big coffee machine. You remember the old Coke-sized coffee machines? You paid 50 cents for, and you got a cup of mud basically. So at that time, the Keurig was just coming out, and a representative came in and brought in a Keurig coffee maker. He said, "Get rid of that big clunky coffee maker that everybody hates and put in our Keurig brewing system." It was actually W.B. Mason that was trying to sell it to us. So we definitely consider it. I said, "Can you bring in one of these systems for us to look at?" And what he did is he brought in two Keurig coffee brewers, and one was a standard brewer, and the other one had a coin mechanism in it, so you could pay for coffee, because some companies want to subsidize the cost of their coffee. And then what he did is he opened up a box of K-cups, and he put it next to the brewer, and he showed me how it worked. Take the K-cup, put it in this brewer, put the K-cup, put it in the second brewer, but you got to put 50 cents in the brewer in order to get your cup of coffee. And I said to the sales rep, I said, "Now that doesn't make a whole lot of sense to me, because basically you're paying 50 cents for the water. So the real value is sitting in that box you just opened, that's sitting out on the table." I said, "There really should be some kind of vending machine for the K-cups." And that was my aha moment, if you will. You know what he said to me? My customers ask me for that all the time. I went home that evening, pulled my father out of retirement. He was a retired mechanical engineer. And we sat in his office and started designing a K-cup vending machine. It's now known as the coffee carousel. We built a wooden prototype, predominantly wooden prototype, down in the basement. My dad does a lot of woodworking as a hobby. I took it to a trade show out in Las Vegas called the NAMA, National Automatic Merchandising Association trade show. We unveiled our wooden prototype K-cup machine right next to Keurig's booth, and next thing we knew, we had companies like Office Depot, Staples, W.B. Mason, Costco, all interested in the product. Tried to license it to Keurig. Came close, they decided they didn't want to be in the vending business. So I ended up having to produce it myself. So we made a trip overseas because there was another machine on the market. It was great, but it was too pricey for what the small businesses were looking for with Keurigs. It was comparable to the Coke machines, close to $3,000 at that time. So we knew if we were going to compete with them, we needed to serve the smaller clients, of which at that time there was about 4 million Keurigs installed in small businesses. So we came in with a machine that sells for $4.99. It's an all-mechanical machine based on the traditional gumball machine. So that's pretty much my story. And yes, the UConn Law Clinic did help me in patenting the device. And as you know, I was first to patent it, and others have since produced it, but that's a whole separate issue. So, but it's been fun. It's brought my father and I abroad several times. I'm actually going back to Vegas with hopefully a new generation of the machine in April.
So are you selling these things now?
I do sell them, yep, sell them through all the major office supply companies. Of course, you won't see them ever advertised, in their catalog. Because, for instance, I don't know if, we get our K-Cups through WB Mason at work, okay? All of the major office supply companies furnish K-Cups and they furnish Keurig brewers. They make their money off of selling K-Cups. So the issue that, the real problem came about is when Keurig first introduced their machine in 1999, it was a $900 brewer. So their target market at that time was strictly businesses, high volume accounts. It wasn't until 2006 where Green Mountain bought Keurig out and decided to introduce their brewer to the residential market. And that's obviously, you're all familiar with Keurig now. They became wildly successful as a result of introducing it to the residential market, but it posed a problem for all those companies that had the Keurig brewers. Because now the employees going into their business, making a cup of coffee in the morning, putting 2 K-Cups in their pocket to take it home at night. Which WB Mason has no problem with, okay? The more pilferage that was taking place, the better. So what started happening and drove demand for me is customers are saying, hey, now that these things are available everywhere, my employees are taking all these K-Cups home from me. He says, you gotta find another solution. Take this Keurig brewer out of here and give me another solution. And that's when they'll tell you about my K-Cup vending machine. So Brad, keep your Keurig machine. What we're going to do is we'll give you a free vending machine to control the pilferage problem you're having. So even though WB Mason buys them from me, if it's a large enough account, they'll actually place a vending machine into the break room with customers. Yeah, we're in break rooms at Home Depot. We're in break rooms at Costco. Costco actually sells it for us up in Canada. Yes.
It sounds like you were saying you've been infringed on your patent, is that correct? And if so,
Michael, I've been infringed on.
it sounded like you were.
Yeah, somebody else has come out with an all-mechanical machine, very similar to our design. So it's something we're looking into. Their footprint is exactly the same. The weight of their machine is exactly the same. The language on the machine in terms of how it operates is verbatim with our machine. So that's we're still on the fence as to whether or not to pursue it. I think this new generation we're coming out with is probably going to pull us well ahead and eliminate the concern and the threat.
How did you get your funding to do your initial production run?
That was interesting. When I went to Vegas, okay.
I like this story.
There wasn't a slot machine. No, that would have been nice. I had this wooden prototype, and I had showed it to Keurig. They told me they weren't interested in being in the vending business, but they said they put me in contact with their distributor out of New York, out of New Jersey, world's largest amusement, coin-operated amusement distributor. And so I went down there, and lo and behold, it was 3 weeks away. They were going to Vegas, big booth themselves, or they were going to show off a lot of their vending equipment. And I said, would you consider taking this machine and putting it in your booth? And so they called him the vice president of sales, and he pointed out everything that was wrong with the machine and why he didn't want it in the booth. So he gave me a whole list of things that were wrong, but he said, I tell you what, we'll take the machine out to Vegas, we'll show it to some people, we'll see if there's any interest in it. So my father and I spent the next 3 weeks going through that list of everything he didn't like and correcting those problems. So I went out to Vegas, the salesman saw it, he said, you know what, we're going to put it in our booth. So that's when Office Depot and all those people approached us. At the end of that trade show, I sat down with the owner of that company, and he says, I think you're really onto something here. He said, do you have a manufacturer? I said, oh yeah, I've got this manufacturer lined up in China, ready to go. I'd exchanged 3 emails with him at that point, actually. And he said, what kind of funding was it going to take to get us into production? So I threw out a number, which I thought was right. I had been thinking about that for a little bit. And on a handshake deal, he says, we're gonna go back to New Jersey, got a board meeting in 2 weeks. He says, and I'm gonna get the funding for you. He says, in the interim, we need to get the market fast before somebody else does. He says, make your planning reservations to go see your manufacturer, okay, book your hotel, and get over there and start tooling up. So I did all of that. 2 weeks came, 2 weeks went. I was supposed to leave for China a week on the third week. 3 days before my flight, he called up. He said, the board met. He says, they decided they want to get out of the coffee business. So there I was with a hotel reservation and a plane ticket to China, and all of a sudden, no money. So what do?
Go.
You go to China.
Yeah.
And I sat down with the owner of the manufacturing company over there, who thought I was going to hand him a check to start all the tooling and buy a full production run of machines, and had to explain to him that I didn't have the funds any longer. So he actually worked with me. Our design was based on a vending machine they were already producing. We bought their machine, we stripped the guts out of it, we re-engineered it to dispense K-cups instead of the other product, which was a plastic toy capsule they were dispensing. So long story short, he agreed to basically provide me with parts for 50 machines. Sent them over here. I had all the unique components fabricated locally. I bootstrapped that. And we spent days and nights in my basement making 50 machines to test the market. So built the 50 machines, sold out of them in a month's time. Took that, reinvested it into the tooling. So at that point in time, we tooled up to have the parts injection molded. And we bought 100 machines. 100 machines turned into 200, and ultimately we were bringing over containers of 480 fits in a 40-foot container. So it was a slow start. But it was nice. It was a nice position to be in. Fortunately, there really wasn't another solution on the market, so I would get orders in, and they were waiting, 12, 14 weeks until we get tooled up into production. But I've got them in stock now. If anybody wants them, 48 hours. So
How much?
$4.99 still. Yes.
Did any of the folks that helped you out take an equity position, or was it just the manufacturer just?
You know what? Quite honestly, I looked into that because it was such a niche market. I had a lot of difficulty in getting people to invest or want to provide funding. I did get some assistance in the form of a grant, very little bit, but it wasn't until the first purchase order came in from Office Depot that venture capital people started calling me. And at that point, I had already had an arrangement, with the manufacturer overseas, and I had enough funding to bootstrap it. So,
Great.
answer your question.